Hi guys, welcome to Let's Get to the Marks. Going to work through some redox, half equation, exam questions. So let's get to it. A student oxidized a solution of hydrochloric acid with a few drops of sodium chlorate 1 solution. The reaction mixture effervesced and turned pale green. The gas formed bleached universal indicator paper. Sounds like chlorine. Okay, let's point out some bits here. So, first of all, something to notice here, sodium chlorate. What does ATE mean? Hopefully you know by now that ATE means that the compound ion molecule, whatever it is, contains oxygen. What does this 1 mean in Roman numerals? The 1 gives us the oxidation state. In this occasion, it's for the chlorine. Anyway, let's get back to that. Write a half equation for the oxidation of chloride ions. Now this brings us to what is oxidation? Well, hopefully you remember oil rig, which you most probably have been taught, oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So oxidation is loss. So the oxidation of chloride ions. So we're starting with chloride ions. So we can start with a Cl. It's an ion, so it's going to be positive or negative. It will have either lost electrons and be positive or gained electrons and be negative. How do I know which one? Well, when non-metals like chlorine tend to gain electrons, the word ends in IDE. That tells me it's a negative ion. Now I need to know what the charge is on that negative ion. Well, chlorine is in group 7. It needs 1 electron to complete a full outer shell. So chlorine forms a -1 ion. Spare glasses. Okay, so there's our chloride ion as an oxidation state of -1 chlorine generally. So there's chlorine. Okay, it's going to lose electrons. So when you lose electrons, you put the electrons on the right-hand side like that. It's going to lose that negative charge. So that's what that E is. And going to become chlorine. Now we know that chlorine is diatomic. All of the halogens are diatomic. Nitrogen, hydrogen, and fluorine are also diatomic. Have no fear of ice cold beer. That covers most of the diatomic elements. Now, if I put 2 here, we need to balance this, and a 2 here, I have the nice and easy half equation for the oxidation of chloride ions. Now, that's something that most of you can do because this was a really popular half equation for GCSE when doing electrolysis. So when this comes up, it's like, yes, nice and easy. Okay, let's move on. This gets a little bit trickier. Write a half equation for the reduction of chlorate 1 ions. Now, when you're doing redox equations, one of the half equations is going to be oxidation and one is going to be reduction. So your electrons are going to be on either side of the arrow, depending on which half equation you're doing. So now we're doing the redox half equation, and reduction is gain. So the electrons are going to be on the left-hand side of the arrow. Now, some people may have trouble working out what the hell is a chlorate ion. Well, it's got chlorine in it, and the ATE, as mentioned earlier, this ATE bit means it has oxygen. And we're told by the 1 in the Roman numerals that chlorine has an oxidation state of +1. Hold on, isn't chlorine a non-metal? Doesn't it become negative? Normally. But if it's with more electronegative elements, and there are 3 more electronegative elements than chlorine, you have nitrogen, you have oxygen, and you have fluorine. Chlorine will become positive in that situation. So oxygen, the second most electronegative element in the periodic table, will always be negative. So that's the great one for working out oxidation states. Oxygen's in group 6, so it needs 2 electrons. So it has a -2 oxidation state. And oxygen, whenever it's in a lot of compounds that we deal with in A-level chemistry, oxygen, you can always go as your go-to. It's -2. The only time oxygen is not or does not have a -2 oxidation state is when it's with fluorine. So in this situation, you've got +1 chlorine, -2 oxygen. What's the overall charge of the chlorate ion? Well, it's going to be minus. So this is a group ion with an overall charge of minus. We don't really need the plus and the minus down below. That's just our working out. Now we know that it's going to be reduced. It's going to gain electrons. So we're going to gain an electron, and we're going to become, oh, hold on, we have an extra. I've just noticed. Did you just notice? In acidic conditions. What does this mean in acid conditions? Well, if you haven't studied acids by now, you might not know the A-level definition of an acid, and that is an acid donates hydrogen ions. Basically, if it's in acidic conditions, we have hydrogen ions. So we're just going to start by whacking in a hydrogen ion. So chlorate ions are reduced to chlorine in acidic conditions. So now we can draw our arrow. So when you see acidic conditions, this means hydrogen ions are present. So watch out for that. Now we've been told in this question that it's going to become chlorine. Beautiful. We know it's diatomic, Cl2. When you have acidic conditions, you have hydrogen ions. You are always going to form H2O as a product. So the hydrogen ions are going to go with the oxygen from the chlorate and form H2O. Brilliant. Now all I need to do is I come back over here to the left-hand side and I need to balance all of this up. Well, I've got a 2 here for the chlorine. I can put a 2 here. Now, which I need to do. The problem is if I put my 2 here and double my chlorates, I've doubled my oxygens over here. So what I need to do is put a 2 here, and now my oxygens are balanced, my chlorines are balanced. Unfortunately, my hydrogens aren't balanced, so I need 4 hydrogen ions. Now, how do I know how many electrons to write on the left-hand side over here? Here's a little trick. What we have to do is make sure the electronic charge on either side of a half equation is balanced. So when I come back up to this top equation, I have -2 here. I have 2 minus here. So I have an electrical charge on each side of -2. That's great. Let's go to the half equation below. I have no charge, 0 electric charge on the right-hand side. And over here, I have 2 times minus plus E minus with 4 plus. So if we add that up, I've got 3 minuses and 4 pluses. I'm 1 minus short. I need to add an extra minus in to cancel that out. So both sides have the same electric charge. The way I can do that is add an electron. So there's our half equation. Right, here comes the interesting bit, which can be tricky sometimes. Okay, we have to combine to make the full equation. All you do is take the reactants from both half equations and write them out, and the products from both half equations and write them out. Do you need to change any of the multiplying numbers? Sometimes. This time I don't. How do I know that? Well, I've got 2 electrons here and 2 electrons here. If your electrons balance between the 2 half equations, you just copy the 2 half equations out, you combine them together to make the full equation, cancel out the electrons, and it's all balanced. So it will look something like this. I'm going to go, doesn't really matter the order, but 2Cl minus plus 2Cl O minus, that's my chlorate ions, plus I will temporarily put these electrons here. We don't actually need those electrons, but I'm going to put them there so you can just see in the in your exam, you don't need to bother writing them if the electrons are the same on each side. Now I'm going to write my products on the right, and it's Cl2 oh my gosh, plus 2e minus, talk about slow. Now, if we look down below over here, I've got another Cl, so I need to put a 2 here. It's looking really rough, isn't it? And I need to put plus 2H2O. All of that is great. The only thing I need to get rid of on both sides is the 2 electrons. We don't need you and we don't need you. So there is my final equation. Some people would combine, yeah. Let's just check the charges balance. 2 minus is 4 minus with a 4 plus. That's all balanced. Over here, you've got 0 charge. So both sides equal 0. My equation is complete. Both sides have an electrical charge of 0. So we're done. Dealt with. Awesome. Right. There's our answers. So super, super, super. Okay, I've got a multiple of that. You'll be allowed multiples, so it's totally fine. Yep, great. Let's move on. Next question. In terms of electron transfer, what does the reducing agent in a redox reaction do? So what does a reducing agent do? A reducing agent reduces something else, causes something to be reduced. So itself is oxidized. So the reducing agent is oxidized, but causes something else to be reduced. So it gives electrons or donates electrons to another molecule. That's my reducing agent. What is the oxidation state of an atom in an uncombined element? Right, this is a rule you have to know off by heart. Atoms in uncombined elements, so if you just have oxygen, nitrogen, carbon on their own, chlorine on their own, their oxidation state is 0. Now it says deduce the oxidation state of nitrogen in each of the following compounds. So let's look at this one first of all. Chlorine is -1. Nitrogen here, nitrogen likes to be different things. Nitrogen can be +3, so lovely jubbly. Right, let's look here. We have magnesium and we have, oh, by the way, a -1, you've got to remember that because there's 3 chlorines, you've got to times that by 3, and that makes -3, which means the nitrogen must be +3. Magnesium nitride here. Magnesium we know is +2, isn't it? So magnesium is 2+. We have 3 of them. So 3 times 2+ equals 6+. So when we look at our nitrogen, we've got 2 of those. They must be -3 each to cancel out that. So our nitrogen here is -3. This was +3. Where are we here? We are going to say we have in this molecule here, we have a hydroxide ion. I'm sure you know those are negative. We have 2 hydrogens, which are positive. So we have hydrogens, which is 2 times +1. So our nitrogen in this situation is -1, because we want to get the charges to cancel. So we've got 2 pluses, 1 minus covered there, 1 minus there. And they're the oxidation states of those different species or compounds. Right, let's get on to the redox equation. Write a half equation for the formation of lead 2+ from PbO2 in the presence of, guess what, acidic conditions, hydrogen ions. So lead 4 oxide. You notice the Roman numerals here, the 4. That tells me that lead is at 4 plus in that situation. And it's going to form lead 2 ions, which is 2 plus. So we're going to go PbO2 in the presence of hydrogen ions. Now, you might be wondering, where do my electrons go? Do they go on the left or the right? Is this oxidation or reduction? Which one is it? Well, because they haven't told us if it's oxidation or reduction. So we're going to leave a little space. He says, if you can move the arrow a bit, make a bit more space. So this is the information we know. We know this from the question. We've got Pb2 plus. And what we can do here is find out whether it's been oxidized or reduced. So we know that lead is in a +4 state here. And the lead is going to +2. What does that tell you? If you've gone from +4 to +2, what's happened? You've gained 2 electrons. So we're gaining electrons here. The lead is gaining electrons. So we're going to put +2E minus. We may need to change that in a minute. Don't know why I'm keeping the colors like that. Okay, so we've got O2 and we've got H again. So we're going to make water again. Whenever you have hydrogen ions, you need to make water on the other side. And I need to get rid of this, make a bit of space would be nice. Okay, guys, bear with. Okay, where are we? Right, let's balance up these waters. I've got O2 over there. I'm going to need at least 2 of these bad boys here because I've got 2 O's over here. So I need to have 2 O's over here. That's giving me 4 hydrogens. So I'm going to go back and do the hydrogens now. I've got 4 hydrogens. So I need 4 hydrogen ions. I now need to make the electric charges on either side of my half equation balance out. Let's work out what we've got. We've got 2 plus on the right. So overall, I need 2 plus charge on the left. And I've got 4 hydrogen ions. That's 4 plus. And I added 2 negative electrons to make it 2 plus. So if you hadn't worked out, I did the +4 going to +2 with the lead 4 going to lead 2. But if you hadn't worked that out, you can work that out at this stage. Once you've written the hydrogen ions, you then look at the electrical charges and balance. I needed to add 2 electrons to bring that +4 down to +2 so that both sides are +2. Both this side of the equation has an overall charge of +2 and this side of the equation has an overall charge of +2. I can only achieve that on the left by adding 2 electrons. So if you were confused, that's where we add them. Right, we've already done this. This is the half equation for chlorine. So let's just zip through this one. So, oh no, the formation of chlorine from chloride ions. So we've got chlorine over here. This time we're forming from chloride ions. So this is a reverse. You might say, how do you know that? Well, again, what's happened is this oxidation or reduction. So is this oxidation or reduction? Well, we say that chlorine is -1 there. We draw our arrow going across. It's 0 here. It's lost its negative charge. It's lost electrons. This is oxidation. So we've got reduction above where the electrons are on the left with the lead oxide, and we've got oxidation below with the chloride ions. Now we've got to whack these two together. What do we do? Well, what you need to do when combining is add all the reactants together in the combined equation. So let's do that. 2Cl minus plus, I mean, I can pretty much put them in any way I want, as long as I include all of them. I've got 4 hydrogen ions. Again, do I want to write the electrons out? We're going to get rid of the electrons. You don't need to write these out in the exam. I just want to show you. Did I make a mistake? No, all good. Right. Now, you might want to do a lot of circling in your exam. These are the products. So you might want to circle them. That way you're not going to make a mistake when transferring them down. You keep looking up. You could copy a reactant into the product side or something. So I've got Pb, 2 plus ions, plus chlorine, plus my 2 electrons that I'm going to scrap, and plus H2O. Now, is this balanced? Have I got the right amount on either side? I can tell you yes straight away, because if the electrons are balanced in a redox equation, that tells me that the whole thing is balanced. So I know that the whole thing is balanced. The only thing I didn't do is carry down my multiples. So I need 4. I did put 4 there for the hydrogen, but I didn't put a 2 here. So copy all the reactants down exactly and all the products down exactly, including their multiples, your balancings that you've done from the half equations. And then if the electrons are balanced, 2 electrons and 2 electrons, you just rub them out. So you get rid of these. We don't want these in our combined equation, and that's your combined equation. You can check the charges again. We've got +2 and we've got +2. So lovely jubbly. Right. Let's move on. Oh, check the answers first. There we go. All good. Lovely. Right. Moving on. Donates electrons for a reducing agent, or gives electrons, as they've put there. Right. Let's move on. Okay. This one I wanted to go through as a slightly different example. This is one where the electrons don't balance. What they've done is they've given us the half equations, which is nice of them, here and here. They've given us sodium bromate 5 is a primary standard. Listen to all the nonsense. This means that its solution can be used to check the concentration of other solutions. The half equations for the reaction between bromate 5 ions and thiosulfate ions in the presence of acid are boom, 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 boom. We've been given the half equations. All I've got to do, use these half equations to make the overall equation. I've got to circle the reactants and write them down. Let's do that now. So, in fact, before I write them down, we can do this 2 ways. We could write them down and then balance it after, or we can balance it first with the half equations. So we can either balance this now or balance it after. So let's balance it now beforehand. That might be helpful. Notice I've got 6 electrons here and 2 electrons here. This gives me the opportunity to balance this before we go down below. Right. So what do I need to times 2 electrons by to make them 6 electrons? I haven't explained that very well, but if I times this 3 electrons by 3, I'll make 6 electrons, and then I can cancel the electrons out in the full equation. So when your half equations do not have the same amount of electrons, you need to multiply the smaller one to make the electrons the same. Okay, you sometimes have to multiply both, but you want to get the electrons so that they're equal, and you have to times everything in that equation by your multiplying number. So I'm going to times this by 3 and now have 6. I'm going to times this by 3 and have 3, and the electrons by 3 and have 6 electrons. Now I'm ready to bring them down. Okay, would have been a bit more complicated if I'd brought them down like I was intending to straight away. So now let's bring the reactants down. We go, right, I've got 6 S2O3 2 minus plus bromate O3 minus plus 6H plus. God, it's never going to fit in. Now I'm not going to bother writing the electrons now because we've made them 6 each, so you know they're cancelling and you don't need to write the electrons. Let's write all the products. I've got 3 S4 O6 2 minus, and I've got Br minus, and I've got 3 H2O. Now, Couple of ways to check, does it balance? Is the electric charge on both sides of the equation the same? So I've got 6 times 2 minus, that's 12 minus. I've got a bromate ion, that makes a total of 13 minus, and then I've got 6H plus. So if I whack those together, I end up with 7 minus. Then I come over here, and I've got over this half of the equation, I've got 3 times 2 minus equals 6 minus, and I've got a bromide, that was a bit weird, a bromide ion. So when I whack those together, I get -7. So guess what? Both sides have the same electric charge. This is balanced. Actually, I didn't need to go through all of that. I just thought I'd show you that when you balance those electrons up and you multiply the half equation so that the electrons are the same, everything is going to balance. The electric charges, the numbers of atoms on each side of the equation. Well, that was redox equations and half equations. I hope that's been somewhat helpful. If you want more like this, or you want me to cover anything, leave a suggestion in the comments. All right, guys, good luck with the A-level chemistry, and let's get to the marks.